What up, YouTube? Today we have an old cruise control unit for the Lincoln. It's a perfect circle unit, says it on the side. So we're going to start from the beginning with the whole thing taken apart. We're going to put it back together. So we're going to do it, instead of taking it apart and putting it back together, we're going to kind of look at it from almost like the engineer's perspective so we can really understand how the system works. So stay tuned because this thing's pretty cool. Okay, so this is essentially the base of the unit. I had it all painted, but then the paint was a little sticky when I put it back on the bracket. But anyway, this is the main component that we're going to be working with here. This is kind of the box of it all. So on the front here, we have two threaded sections that stick out. And if you look on the inside, one of them has a gear, a plastic or a nylon gear, and this pin is in here, of course, to keep it from falling out of place. And then if we look inside there, when I spin the gear, that will spin as well. And I know that when I took this off, there was a cable going into the dash off of this. So I know for sure that it does, but let's say that I didn't. We can safely assume that this bottom one goes to the speedometer. There was another cable right here, which will make a little more sense once we put this all fully back together. But this cable comes from the transmission. So I don't want to go too much more into that part yet. But this cable comes from the transmission, this cable goes to the speedometer. And then, of course, we have some wires on the back side, and then we have two vacuum ports here. And those vacuum ports, one says M, which is manifold, I believe. And then the other one says S, and I'm not exactly sure what that means. It might mean suction. I'm really not 100% sure on that. But besides the wiring, that's really the only thing of note on this side. And then over here, we have a spot where the top piece goes in, and we'll look at that here in a second. And then, of course, there's a grooved section here where the seal goes. We're just kind of looking at this base unit from all angles, all sides, just so we can kind of understand what's going on with it. There's lots of markings and labels. The 1, 2, 3 is for the 3 different electrical connections, excuse me, and we'll see that here in just a moment. And then we got our 2 vacuum ports, and that's pretty much it as far as the base of the unit. So the M port, I believe, let me look here. The M port is this one. So, as you can see, there's still sort of a marking there from where the piece that sits on top of that goes. You can kind of see the overall shape of it, and we'll move on to that piece next. Okay, so this is the side of the next piece that faces the inside here. So this part inside there will be facing against this part. And this is a place where vacuum goes through, and then it hops over this ridge here when a valve opens, and it goes over here. And then here's our 3 electrical connections. And that's pretty much all there is to it on this particular side. And in between this piece and the body of the unit that we've been looking at, there was a paper gasket, and at the moment I'm not exactly sure what I did with it, but I did cut a new gasket pretty much identical to the other one, and I've already installed it, and it works much better. It wasn't holding vacuum at all at first, and I put this in there and it would at least get a vacuum, but it wouldn't hold it. So I'm going to put some RTV around these areas where the vacuum goes, and then we're going to reseal it, and we're going to see if it'll hold vacuum, because that's the most important part right now, is to make sure that the vacuum is held whenever this is screwed on. I also want to take a moment to mention, so that the whole video has a better context moving forward, the device we're going to be working on today is a cruise control unit that is vacuum operated. It uses a vacuum to control the throttle opening and also to close the throttle opening. So it will increase vacuum and therefore open the throttle more if more speed is desired. If less speed is desired, it will use less vacuum and therefore close the throttle to try to meet the desired speed. So what I just said, keep all of that in mind as we go through the video, because we're kind of starting at the beginning. We're going to build, quote unquote, a device that will do what I just said. It will use vacuum to open and close the throttle. Okay, so we've got the main control unit, if you will, reinstalled. There's a screw here, a screw here, and a screw here that has to have this green wire connected to it. There's a little L-shaped ring terminal down there. Then on the other side, there's a screw here by the electrical connector, and then there's another screw right there. So there is a total of 5 screws that hold this down, and they're all relatively spread out. You can see the 3, 1, 2, 3. One of them is almost directly in the center of this plastic piece, and then the other one is right here. So they're pretty well spread out. So aside from the main piece, we also have this board that slides in and out of this slot. And I believe on here is a diode, which only allows electricity to flow one way. And I'm only going to explain this to you to the best of my ability. I am by no means a master of this unit or how it works, but I think I have a fairly good understanding of how it works, and we can maybe come up with some theories as to what certain electrical components do and what they're there for. I do not have a wiring diagram. The only thing I've done on here is kind of figure it out based on looking at other YouTube videos and information that I have found online. So keep that in mind moving forward. So we essentially have 2 main parts aside from the wiring. We have the board here with the diode on it that goes in the slot, and then we have the main board here with all of the we'll call them operational components on it. I got the gasket installed underneath it, and we have RTV on both sides of the gasket. We've got all 5 screws in. So I'm not going to check the vacuum yet. I'm going to give that RTV a chance to cure. So anyway, if we look down in here, it looks like I may have screwed up and got RTV in there, so I need to clear that out ASAP. Alright, you can still see a tiny little bit of RTV residue in there, but I've got both of those ports cleaned out, and I've blown air through them and made sure that everything's working properly. So, vacuum comes in through the hole with the big circle right here, and it needs to go across over here, and then it goes through a channel and it exits out the backside. So in order to go full vacuum, this slot here, this ovular slot, is also connected to this passage where the vacuum escapes, but not where it comes in. So if this is open, then ambient air will be mixed with the vacuum, and that will cause the vacuum level at the throttle cable to decrease. Whereas if that is moved over like this, it'll be full vacuum applied, which will be a full pull on the throttle. So this solenoid here kind of works like a clutch. You can see this circular disc on the bottom. Probably could use a cleanup, to be honest, because I don't know if this thing's going to get sticky or not. But essentially, when the solenoid is activated, the clutch will apply and it will move together. But when it's not activated, this piece can move separately, sort of. Like I said, it does kind of get a little sticky. So I may have to do something about that. However, I have already gone ahead and checked this solenoid with the power and ground. I can't remember if I put a power or a ground here, but there's two wires coming off of the solenoid. One comes around over here, which I'm pretty sure is a ground, in fact, because I know this is a ground, this little strip here, and we can talk about that later, but that little contact point is a ground. So I believe I put a ground on that tab way down here on this electric wire, and then I put a power here, and it does apply and it does work, but I think I might want to try to clean some of that scale off of there before we proceed. Alright, so I carefully popped that solenoid off of there and cleaned all the nasty rust and scale buildup off. And now I'm going to put it back together. We got everything lined back up. The spring is in the slot like it's supposed to be. And it's a return spring, basically. This is, whenever it goes one way, that's there to kind of push it back. So let's put it back together. There's also sort of a brass looking washer that goes on before the solenoid, which I believe is also a form of a return spring to push that back up. So I'm going to make sure those tabs are kind of folded properly where it lifts up like it should. That might have been part of the issue as well. All right, now we got the solenoid back on top and this little sleeve as well. Now we can put this little lock washer back on there. There's a little lip. And I'm kind of scared of this old plastic too. Thankfully it hasn't broken. But I think, let's see here. Yeah, it definitely moves much more freely without gripping. But you can still give it a little pressure and it works. So on to the next step. Alright, so I ended up having to take the board back out and put some RTV straight on it instead of with the gasket, because it seemed to leak with the gasket. And there was still an extremely slow leak on the exit side, but I don't really think it was leaking that bad if it's going to be mixed with atmospheric pressure anyway. But I think that we should be good on the bottom board. I also went ahead and installed the second solenoid, which underneath it, you can kind of see where that red foam is. There's another plastic piece under the solenoid. So that piece, let me grab something here. So right under here roughly is where the vacuum in is. And then right here, is where it exits out. And this small little port that sticks off to the side of that plastic. So this solenoid basically moves up or down, and it has a little piece of rubber inside the plastic at the bottom that blocks the vacuum side or allows it to flow. And of course there's a gasket between that plastic piece and the main board at the bottom here. So I'm kind of put some RTV on that, hoping it's going to seal. And then basically this is, like I said, just a valve that goes up and down and allows flow or blocks flow from the vacuum side, which is the M port. And I don't know if you can see in there or not, but you can kind of see the rubber deal in there that blocks the flow. Another thing I want to explain, I should have showed this before I put it on there, and I will show it if this ends up leaking, but the plastic piece with the rubber on the bottom that blocks the flow, it has a metal cylinder that goes up inside of this plastic cylinder that the windings are wrapped around, and so those are two separate pieces here. The bottom piece with the cylinder on it has a wire that goes to the connector here, and that's part of the 3-part connector. And then the red wire goes over here to this board. So we have a black wire and a gray wire that are part of our 3-prong connector here. So there's two wires coming off of this, but I know that it is grounded with the case, or at least I'm fairly certain that it's grounded that way. So I'm not sure how exactly this solenoid is energized. I don't know if this is power or this is power. I'm pretty sure I put power here and ground to the case in order to test the solenoid, but when I put power to the gray and ground to the case, it didn't really do anything. So I'm not sure if the gray is like a secondary ground or if it reverses polarity and tries to pull it up. I'm not exactly sure. But the main thing here that I'm trying to do is make sure we have no vacuum leaks, because like I said, I've already tested all of these 3 solenoids, 2 you can see here, and then the other one's in the top. So all of those are working. All of this is working electronically. So I think if we can fix the vacuum leak, we should be good to go on this being a working unit. Alright, so I've been working on this thing a little bit more, and I just want to throw a few other things out there. This piece on the board right here, I thought it was a diode, and it could potentially still be a diode. But another consideration that I thought of is that it could also be a resistor, which would make there be less current flow to whatever's on the side of the board that's being resisted. Also, I've messed with this valve some more, and I don't know if you can see that metal spring down there. I'll try to get something to point at it for you. Come on now. Oh boy. Alright. So down in here, where I'm touching my screwdriver, you can just barely see the bottom of a spring. And then I also have a little rubber washer underneath it. That rubber washer is replacing these 2 paper washers that kind of got torn up. So I wanted to replace that with something. And then in order to hold that rubber seat down that's inside of this solenoid, remember I said that this solenoid right down the middle has it's got a hole basically. So right under this screw, if I were to take this screw out, we could basically look down and see in the middle of this cylinder shape here is sort of a metal rod that's about the same width as the center hole. And a magnetic field goes through this winding here, and it will cause the metal piece in the center to be lifted up towards this point, and that will allow the vacuum to go from the center area here where it comes in from the manifold, and it will allow it to cross over and escape through here, where it will then be mixed with atmospheric air through this slot, and it will be exited out of the other port on the back to adjust the throttle. So I finally also have this solenoid set up where it's holding vacuum, and I will show you guys that, and I will show you guys the solenoid operating. I'm sorry I didn't turn my camera on while I had this solenoid apart so you could see kind of the pieces of it. Like I said, this bottom plastic base is a separate part that has that sort of cylinder attached to it, the metal cylinder that goes through the middle of this solenoid. And then of course there's a small rubber gasket. I tried RTV on that and that didn't really do anything, so I ended up just kind of rubbing the RTV off and just using the gasket straight up. Once I found the right spring to hold this down, then it was holding vacuum for me. I basically just found a couple springs and I just cut a little bit off at a time until it had enough spring tension to hold the seat down, but weak enough that the solenoid could still compress the spring. And I mean, I ended up, this is a similar piece to what's in there, but I probably cut it off right where my fingernail's at. So I mean, you just barely have any movement to the spring, and that's pretty much what it took. So I'm gonna get this all set up here and then we'll show it in action. Alright, so here we have the top unit, and as you can see right here, there is a hole in it, and that is where the atmospheric air will enter the unit. And there was a tiny little air filter inside there, but it got crumbled up real nice. So I found a piece of foam here, and I'm going to replace the cruise control air filter just to try to do the best job that I can on this. Who would have thought that your cruise control has an air filter? You work on cars for a long time and you still see firsts all the time. I must say I've never ever seen a cruise control air filter. Anyway, over that little section where the air comes in, we have this little plate. The air comes in on this side because it's of course upside down, and then it goes across here and it goes through this area, and that's where it will escape into the unit. But we also have this sort of screw deal sticking up there, and that is going to be blocked by the other side here, and we can take another look at that in a second. And then of course we have a seal, and since this is just for the atmospheric air pressure, I'm not super worried about that. But as you can kind of see, that's covered up or pretty well sealed by the cover. So I did want to show you that. And now that you've seen that, we got a new little filter in there. You can see how the airflow travels. I'm going to go ahead and put these 4 screws in. Alright, so we got that cover back on. And then, still not 100% sure what this second little port here is that screw goes into. Not exactly sure why that's there, because as far as I can tell, it never makes any electrical contact with anything. But anyway, this solenoid goes on to the cover, and you can just kind of barely see in there. I will show you what it looks like when you push down on it. You might be able to just barely see it moving in there. Goes up and down. So whenever this is energized, it will block flow coming in through here. And on the other part, which I'll show you in a second, when this is not energized, this is touching a metal tab, and when it's energized, it disconnects from that tab. So I'm going to go ahead and put this little cover back on. It screws in right here. You can kind of see where it went before. This is in some ways like an air filter in and of itself, and then of course we have the foam, so I'm going to screw that back on now. And that's what that looks like. Alright, so I think I've done just about everything I can to reseal the bottom of this. So I'm just going to kind of put it back together to the best of my ability and hope that it works. Note how this screw is pushing against that little metal tab there, which is breaking the connection between the two. And then when I move it, they reconnect. You can see how that separates there. So that's very important that this gets lined up that way, but I did go ahead and put this back in, rotated it a few times with the weights in and out, making sure that nothing is going to hit. And then you also want to make sure that this, there's a rectangular rod sticking out of this shaft here at the bottom. You can see that spring is connected to it. And then deep down in there, you can see there's a hole in the middle of it with a pin sticking through it. And so that connects to that solenoid we were messing with earlier. And when this moves, they move together. So that's got to be like that. If you can see how that works. Hopefully that makes sense. So I got this put in there. If you're confused on which way it goes, the weights go on this side in the big chamber where there's nothing in it. And then also there's a square hole in the end of it that fits the cable. So make sure it goes in like that. And then now I can put this piece back on. And for now, I don't know if I'm going to bother to put any sealant on this or on the top, because I think this is just atmospheric air inside here. And so I'm going to just kind of put it back together and test the system. Once I get ready to drive the car, we can test the system. And then if there's any issues with it, we can address those at that time. But for now, we're going to put it back together because I believe the vacuum part is fairly well sealed up. And we know all three solenoids work. So as long as the vacuum is holding, I would imagine that this will work. But obviously, I'll never know until I get to test it. And I can't test it till I rebuild the engine and the brakes and a number of other things. So we're going to go ahead and get this one going for now. Alright, so this piece right here, I want to throw out that it goes in here and it holds the spring in the other end for this piece that we've got in here, and it's calibrated to this kind of 30 mile an hour sort of speed or whatever. And so this piece can actually slide back and forth, and it is actually not a good idea to loosen this screw at all. I had done that, and then this whole cylinder slid downward, and when I put it in, I had a lot of play in the spring, and I was super confused why it wasn't, you know, flush like it used to be with the spring butting up against this. And it's because this actually slides. So I found the spot that where the screw was screwed into on this piece of metal. You can see a little dimple in it, and so I slid it to the correct location, and we're good to go. I just wanted to throw that out there in case it happens to anyone else, or you can just avoid it from happening completely by leaving this screw alone. Alright, so I've gone ahead and screwed this piece back into the actual housing of the unit here, and with this piece extended back out where it's supposed to be, we have no free play. I mean, we can compress the spring a little bit, obviously, but before, when I tried to install it, this piece was slid all the way to the right, and this spring was just wobbling around in there, so it wasn't really working right. But now I have the correct amount of spring tension, and if we move one of these centrifugal weights, we can see the spring compresses and our solenoid clutch at the bottom moves, so that's good. And so I've gone ahead and tightened those up. I didn't bother replacing the factory seal. I'm still not 100% sure if this unit is supposed to hold vacuum inside or just underneath the plastic piece. So for now, I'm just going to reuse the factory seals. Everything inside here is put back into place. So I'm going to demonstrate kind of how it looks when it's working. Then I'm going to put the cover back on. All right, so we got a drill here in the side with a square bit that's going to connect to this. So when you're going at a low speed, not really affected. It's got that 30 mile an hour, but once you get to that point, that screw will lift away and those tabs will connect. And then that's kind of what it looks like as you go faster and faster. You can see your solenoid clutch moving, the springs compressing. Go really fast and then go back and forth a couple times. That's kind of what this whole mechanism is going to be doing. Letting vacuum in or out, mixing it over and over with regular air pressure. So hopefully everything works out with this. Like I said, all the solenoids are working and we got everything put back how it's supposed to be, and I believe that I've got the bottom sealed up. So now I'm going to go ahead and put the cover back on, once again just reusing the factory seal. Alright, so before we put the top back on the solenoid that's on the lid, there is a tab sticking out. We do need to take this wire here that sticks out of our diode board, and we're going to make sure that goes connected before we screw the top of this lid on. Just like that. So the bracket, I had it all painted and set up, and I wasn't real pleased with the way this particular part of it looked. There was still a lot of evidence of rust or corrosion on it, and I didn't really like that. So I sanded this part down because that's the main part you're going to see when the hood's open. So I at least want this section to be real nice and smooth and shiny. I don't know if I've said this on the channel before, but we're really only going for about a 7 out of 10 on this car. So I'm going to do the best I can, but I'm not going to go overboard. So we're going to repaint this and see what it looks like. So I went ahead and got the top screwed back in, and I got the wiring harness all put back on and routed correctly, and we've got this piece painted a little better. So I'm going to go ahead and let that dry, and we'll bolt her up, and then it should be totally finished. May need to wipe down the paint dust as well, but it should be pretty much all finished up. Then hopefully whenever the engine and all that's done, we can test it and it just works great. Alright, and this is pretty much what the finished product is looking like. This paint is still wet, but this is our, it's like a little relay or something here. And I'm going to wipe this down real good once that paint dries, because it's still a little dusty there. But we got a brand new rubber bellows here, they call it. It's like a boot for the vacuum. And then when this gets filled with vacuum, there's a little piece here and a cotter pin that holds the throttle cable. So it'll pull the throttle cable when the vacuum is applied. And then I believe that this actually connects to one of these two ports. Let me double check on that, and I'm going to connect that up. So it's the side that says S. That makes sense, because the M, I do remember, was for manifold, and so the S must be for suction, which is going to apply the suction to this. We got a brand new hose here as well. So that is pretty much what our finished cruise control unit assembly looks like for the 1969 Lincoln Continental. There is just a little pin inside here that I got stuck together, and then we've got the cotter pin here for once we do connect the cable back up. And so this is essentially ready to install into the vehicle. And that's going to be the end of the video for today, guys. Hope you all enjoyed. This particular video took me honestly several months to make, I think, just figuring out how all those pieces work and trying again to reseal that piece on the bottom of the body there to keep the vacuum, you know, sealed. And I just got kind of fed up with it, and I figured it was old, it probably wasn't going to work to begin with, but I figure at least until I can test it and figure out why it doesn't work, if it doesn't work, I might as well just throw it back on the car. I did get a great understanding of how the system works though, and hopefully it will just work. You know, we can just throw it in there and it'll work great. But you know, if we do have any issues, we could of course address those later. I just don't know if it's not going to work, and if so, why. So we're going to put that into the future. We will be putting that back onto the fender in a future video when I get to the engine bay. We're going to be doing that up real nice once the engine's out. Anyway, go ahead and like the video. Go ahead and leave a comment below, and if you haven't already, go ahead and subscribe to the channel. I'd greatly appreciate all three of those things. Otherwise, this is Andy signing off, and I will see you on the next one. Cheers.